Hello and welcome to this video where we will be going over paper 3. Using the advanced information that has been released by the exam boards, this is a predicted paper that contains all the topics that you need to know for paper 3 for the GCSE higher tier mathematics exam. We will be starting from the back and working our way to the front. Let's go. So the first question that we will be looking at, which is actually the last question on the paper, there are some red counters and some blue counters in a bag. The ratio of red counters to blue counters is 3:1. Two counters are removed at random. The probability that both the counters taken are blue is 1 out of 20. Work out how many counters were in the bag before any counters were removed. So it's a probability question that we are dealing with, which is quite clear. Let's start off by writing down this ratio of red to blue counters. So we are told that red to blue is in the ratio of 3:1. Now we don't know how many counters are in the bag, so what we'll do, instead of writing just 3:1, we'll write 3x and 1x. Of course, you don't need to write a 1x, you can just write x, but I've just left it there so that you can see the ratio 3:1. Next, we'll write down the information. The probability that both counters taken are blue is 1 out of 20. What does that mean? It means that the probability of a blue and a blue is equal to 1 over 20. Now, let's write down what the probability of a red counter and a blue counter actually is. So the probability of a red, we can write that as 3 out of 4 because 3 and 1 make up 4 parts. So 4 will be our denominator. As for the probability of a blue counter, then that's going to be 1 out of 4. Now, we know that two counters are removed at random, and we've been given the probability that both these counters being blue is 1 out of 20. But what's the answer that leads up to 1 over 20? Well, we want the probability of a blue and a blue. Now the probability of the first being blue is 1 out of 4. What's the probability of the second one being blue? Now, what we want to do is work out the total amount that we have. So we know that 3x plus x is equal to 4x. So all I've done here is just added this up because this gives me 4x. So the denominator will be 4x. Next, what we can do is write down a generic probability of getting a blue. So the generic probability of a blue would be x, which is the probability of one blue, over the total, which is 4x. Now, what we can do is say that the probability of a second blue would be x over 4x, but remember, when you are finding the second blue's probability, you have to remember the first blue has been already taken out. So one blue would be less, and one from the total amount of counters will be less. That means that we will take away 1 from the top and the bottom, giving us a fraction which is x minus 1 over 4x minus 1. So this here is the probability of a second blue. So what we can now write is the probability of a blue and a blue is going to be the probability of the first blue, which is 1 over 4. That's quite simple, so 1 over 4. Times by the probability of a second blue, which is what we've just found right here. So that's going to be 1 over 4 multiplied by x minus 1 over 4x minus 1. And we just have to calculate what that is. But we also know that this is equal to 1 over 20. So we can write 1 over 20. So let's go ahead and simplify that. So on the left hand side, we are just going to multiply the numerators, which is 1 times x minus 1, which is simply x minus 1. And on the denominator, we have 4 times by 4x minus 1. And of course, that's equal to 1 over 20. Next, we can do one of two things. We can either multiply this bracket out, or we can cross multiply. So this will multiply up here, and this 20 will multiply up here. So let's go ahead and do that one. So 20 bracket x minus 1 would be equal to 4 bracket 4x minus 1 times by 1, which we don't need to write. Now we can just expand the bracket, so 20x minus 20 is equal to 16x minus 4. Take the x's onto one side, so the 16x can go over there, and the minus 20 can go over there. So 20 minus 16x is 4x, and the minus 4 plus 20 is equal to 16. So now we have 4x is equal to 16, and therefore x would be equal to 16 divided by 4, and that gives us 4. So that's the value of our x. So now, if we go back to the question, it says work out how many counters were in the bag before any counters were removed. We know that there were 4x counters in total, because this bag only contains red and blue counters. So to calculate the total number of counters, we know that it was 4x, so therefore x is 4, so it's going to be 4 times by 4, which is 16. So there were 16 counters in total in the bag. Question 22. Solve algebraically the simultaneous equations. X squared minus 3y squared is equal to 13, and 2x plus 3y is equal to 4. Step number 1, we are going to label our equations 1 and 2. We're going to take the linear equation, which is the second one, and we are going to make something, either the y or the x, the subject. I'm going to make the x the subject. So in order to do that, we have 2x plus 3y is equal to 4. I'm going to take the 3y to this side, and then I'm going to divide by 2. So that will give me x is equal to 4 minus 3y divided by 2. So now I have x as the subject. Next, I will just take my value of x and substitute it into equation 1 right there. So sub x into equation number 1. So I get 4 minus 3y over 2 squared minus 3y squared is equal to 13. Next, I will expand that bracket out. So that is 4 minus 3y squared over 2 squared minus 3y squared is equal to 13. And of course, on the top, I get 4 minus 3y and 4 minus 3y again, all over 4 minus 3y squared is equal to 13. So let's go ahead and expand those brackets. So 4 times 4, that gives me 16. 4 times minus 3y is minus 12y, and then we get minus 12y again from minus 3y times by 4, and then minus 3y times by minus 3y is a positive 9y squared. That's all over 4, and then continue writing 3y squared is equal to 13. Let's collect the like terms. So we have 16 minus 24y plus 9y squared all over 4 minus 3y squared is equal to 13. Let's go ahead and get rid of the denominator of 4 by multiplying by 4. So we'll multiply by 4. That gives us 16 minus 24y plus 9y squared, and then we get minus 12y squared, and then 13 times by 4 is 52. Next, we'll collect all the like terms here. So we've got these two which are alike. So 9 minus 12, that gives us minus 3y squared, minus 24y plus 16 is equal to 52. Now, we want to have a positive y squared. So we are going to take over everything here onto this other side. So that gives us 0 on this side, and we have a positive 3y squared. We have a positive 24y, and then 52 minus 16, that gives us plus 36, and we now just need to factorize this. Now you'll notice that we can divide everything by 3. So let's go ahead and divide everything by 3. That gives us 0 is equal to y squared plus 8y plus 12. Now let's go factorize this using the AC method or otherwise. So when you factorize this, you should have two brackets. I'm going to write the equal on this side now. It's the same thing as writing equal on the other side. So I have y, 6 and 2, that's a positive, and that's also a positive. So therefore my values of y are minus 2 or minus 6. All I have to do now is go and find my values of x. So what I'm going to do is I'm just going to reduce the size here so I can have more working space. So if I have y is equal to minus 2, I'm just going to go and substitute it into the equation right here. So 2x plus 3y is equal to 4. So I'm going to sub it in right there. So 2x plus 3 times y is minus 2, that's equal to 4, and 2x minus 6 is what I get from that, and that's equal to 4. Take the minus 6 to the other side, so I have 2x is equal to 10, and therefore x is equal to 5. So one of my solutions is 5 and minus 2. I just have to find the other one. So now let's substitute y equals minus 6 into the same equation, equation 2. So 2x plus 3 times y is minus 6, that's equal to 4. So I have 2x minus 18 is equal to 4, and then take the 18 to the other side, giving me 2x is equal to 22, and therefore x is equal to 11. So that's my second solution, 11 minus 6. Question 21. Here are two right-angled triangles. Given that cos of A is equal to the cos of B, find the value of x. Okay, so what do we have here? We have two triangles, and we've been given the two lengths right there, and also the two lengths right there. And we're told that the cos of A is equal to the cos of B. So we are going to be using here SOHCAHTOA. So let's write that down. And since we already know that we are going to be dealing with cos, let's highlight the cos part of it. So let's go ahead and label our first triangle. This will be the hypotenuse, hype, and this side here will be adjacent. And of course on this side we'll have hype, and this side here will be adjacent. So for the first triangle, we have cos A is equal to adjacent, which is our x, divided by our hypotenuse, which is 4x plus 3. And for the second triangle, we have cos B, which is equal to our adjacent, which is 3x plus 2, over our hypotenuse, which is 27x plus 4. Now we know that they are both going to equal each other because we are told this right there. So we can equate both of them. So let's go ahead and do that. So x over 4x plus 3 is equal to 3x plus 2 over 27x plus 4. Now I'm sure you know what to do next. You are going to go and cross multiply. So we have x bracket 27x plus 4 is equal to 3x plus 2 in a bracket and multiplied by 4x plus 3 in a bracket. Expand those brackets, we get 27x squared plus 4x is equal to, the second side is going to be 12x squared plus 17x plus 6. We are going to collect everything onto one side, giving us 15x squared minus 13x minus 6 is equal to 0. And here we are just going to factorize this. Now there is nothing that we can divide by here to make this a more simple equation, so we're just going to go ahead and use our AC method or otherwise. So let's go ahead and use our AC method. So we're going to multiply the 15 and the minus 6, giving us minus 90, and we are going to find the factors of minus 90. So we have 1 and 90, we have 2 and 45, we have 3 and 30, and we have 5 and 18. Now 5 and 18 are the ones that we need because we're going to add them to give us minus 13, which is the one in the middle, the minus 13x. But what kind of signs do they have? We need to add to give minus 13, so it's going to be a minus 18 and a positive 5. And when they multiply, of course, they're going to give you minus 90 as well. Now, there may be a particular method that you use to get them into the brackets, but I'm going to be using one of them, which I've got on my channel. So what I'm going to do here is I'm going to write 15x without the square over the plus 5, and again 15x without the square over minus 18. And those are the values that I get from here. So that is there, and this is here. And this 15x is from there and going on to those numerators. Next, I will simplify the fractions. So 15 and 5, they can both be divided by 5. So when you divide that by 5, you get 3x on the top and 1 on the bottom. So you have 3x plus 1 as one bracket, and the second one you can divide by 3. So when you divide 15x by 3, you get 5x, and divide that by 3, you get minus 6. So the second bracket is going to be 5x minus 6. And that's, remember, equal to 0. Let's go ahead and make some room now. So What do we have for our first bracket? We have x is equal to minus 1 over 3, and for the second one we have x is equal to 6 over 5. Now if you go back to the question, we have a side, a length, which is just x. So we can't have a negative value here because we'll have a negative length and we can't have that. So we'll only use that. So this is negative and lengths cannot be negative. So our value for x is 6 over 5 or 1.2. Question 20. We have f is equal to the square root of g divided by h. We are told that g has been rounded correctly to 3 significant figures. H has been rounded to 3 decimal places. By considering bounds, work out the value of f to a suitable degree of accuracy and give a reason for your answer. Let's go ahead and work out the upper and lower bounds for both of our values. So for g, we have 12.7 and we're going to put those signs in. I have a lesson on this on my channel, upper and lower bounds. Do go and check that out if you need more help on that. So if it's been rounded to 3 significant figures, we are going to have 12.75 and 12.65. And for our h, which has been rounded to 3 decimal places, the value is 9.294. Once again, those signs. So we're going to have 9.2945 and 9.2935. Next, we are going to consider the upper and lower bounds for our f. So for the lower bound, we are going to do the square root of the maximum divided by the minimum. Now, just a quick reminder, like I said, I do have a lesson on this on my channel, but as a reminder for this particular question, when you want to find the lower for a fraction, you do minimum divided by the maximum, and when you want to find the upper value for a fraction, you do maximum divided by the minimum. So let's go ahead and just box that up. So we are going to be using this, so we need to find the lower f, so we want the minimum value of our g. So the minimum value of our g is right there, divided by the maximum value for our h, and the maximum value for our h is right there. So it's going to be 12.65, the square root of that, divided by 9.2945. So the square root of 12.65 divided by 9.2945. And if you work that out on your calculators, you get 0.3826654331. Now for the upper of f, let's get rid of the h actually, because that might be confusing to some of you. I put a h for higher, but let's use u for upper. Right, so for the upper, we want the maximum for our g. So the maximum for our g is 12.75. So the square root of 12.75 divided by the minimum of our h. So the minimum of our h is 9.2935. So let's go ahead and work that out. So on your calculator, you should get 0.3842163033. Now, the question says, by considering the bounds. We have considered the bounds. This is the lower bound and this is the upper bound. By considering the bounds, work out the value of f to a suitable degree of accuracy. So in order to do that, we look at both of our answers for the upper and the lower bounds. Now, if you look at both of them round to the same 2 decimal places. So if you have a look at the first 2 decimal places here, you can see that this rounds to 0.38 if you round to 2 decimal places, and this also rounds to 0.38 if you round to 2 decimal places. So the final answer of f to a suitable degree of accuracy is 0.38. And there you go. Alright, so question 19. The table shows information about the time in seconds taken for some people to run a 100-meter race. Use the information on the table to complete the histogram. Part B, it says use the histogram to complete the table. So let's go ahead and zoom out like this. Hopefully you can see everything. So what are we dealing with here? We are dealing with histograms, and you need to know the formula for frequency density. The formula for frequency density is frequency divided by the class width. And you can rearrange that in terms of whatever you need to find. So if you want to find the frequency, then you can multiply the class width on the other side. So frequency density times by class width is equal to frequency. Now, we want to use the information on the table to complete the histogram. Currently, we don't have anything here. Okay, this is completely unmarked and we need to find out what each of these squares are equal to. But before we do that, let's go ahead and append or add to our table here. So what we are going to add here is frequency density. So I am going to calculate the frequency densities of the ones that I can find. So zoom back in. Our frequency density for our first interval 10 to 12, our frequency is 6. So it's going to be 6 divided by the class width, which is 2. 10 to 12 is 2. And that gives me 3. So the frequency density is 3. The next one is going to be 21 divided by the class width, which is 1. So that's going to be just 21. Third one is going to be 23 divided by the class width, which is 1 again. So it's going to be 23. We can't do 14 to 16 just yet, but we can do the last one. So the last one is going to be 8, the frequency, and divided by class width of 4. So that gives me 2. Now, if you look at the table and your graph, you will see that the last class interval has already been completed in full on your graph. So we can use this as a way to figure out what these values are. We know that the frequency density for 16 to 20 is 2, which means that this here is equal to 2. So let's go ahead and zoom in here. So we know that it's equal to 2. So we know that this right here is equal to 2. That means every 2 squares is equal to 1. And we can now use this to fill in the rest of our y-axis. So this will be 3, this would be 4, and this would be 5. So 2 big squares is equal to 5. So let's go ahead and write this. This is going to be 10, this is going to be 15, this is going to be 20, and this is going to be 25. So what we now can do is fill in all the other bars. So if you look at 10 to 12, we know that the frequency density is 3. So 10 to 12, the frequency density is 3, and that's going to be there to there and there. Make sure that you use a ruler. And then for 12 to 13, we know it's 21. So 12 to 13, 13 is going to be right here. So it's 21. So 21 is going to stop right there. There you go. Now 13 to 14, 13 to 14 is 23. So that's 13 to 14 right there. So 21, 22, 23 is going to be there. Right there. Now 14 to 16. 14 to 16 we didn't have anything in our table, but we now know that for 14 to 16 it goes to 21, the frequency density. So we can come in here now and say that the frequency density is equal to 21. Now remember earlier on I said that you can manipulate this formula in terms of whatever you want to find. Now we want to find our frequency right there. So we are going to make frequency the subject. So that's going to be frequency is equal to FD times by the class width. Now the FD we know is 21. So it's going to be 21 times by the class width, which we know is 2. So 21 times 2, that gives us 42. So our frequency is 42. And now we have completed our histogram. And we have also answered part B, which says use the histogram to complete the table, which we have done as well. Okay, question 18. The diagram shows a triangular prism. We've been given that the length C to D is 20, A to D is 30, and the angle ADC is equal to 35. Calculate the size of the angle the line AF makes with the plane ABCD. Give your answer to free SF. So let's draw this line A to F in. So that A to F is right there, and the plane ABCD is on the floor right there. So what angle does it make with the floor? Let's draw a line right there, and we also can complete this right angle triangle. We are looking for this angle on the floor right there. I do have a lesson on 3D Pythagoras on my channel, so do go and check this out. Although this question does use trigonometry, and I don't think at the time of making this video I have a video for 3D trigonometry, but it's the same concept. It's knowing how to draw these triangles in a 3D space, which I explain in that video. So back to this question, let's go ahead and draw our triangle. the triangle ACF. So this is A, this is F, this is C, it's a right angle. We are not given any of the lengths at the moment, so we don't know what this is, we don't know what this is. But we want to find what this angle right there is. How do we find those missing lengths? Well, we'll look at other triangles. The first triangle that we can consider to find this length FC is right there. So let's go ahead and draw that separately. So F, C, and D, all I've done just quickly is drawn this. So we know that D to C is 20 centimeters, and we also know this angle right here, which is 35. So that is 35. Right, so we are looking for F to C right here. Let's label our triangle. This is an opposite side, this is adjacent. So what uses opposite and adjacent? We use SOHCAHTOA, so SOHCAHTOA. So we are going to be using opposite divided by adjacent. So tan 35 is equal to opposite, which is our FC here. So we can call it a question mark for now, or you can call it a letter unknown. So let's call it something like X. So X divided by our adjacent, which is 20. And we just need to find what our X value is by doing 20 times by tan 35. And X gives us 14.0041 ... We can also round to 2SF or something like that. But remember, the final answer needs to be rounded to 3SF. If you start rounding early here, then your final answer may change slightly. So it's better to keep your accuracy and keep as many decimal places as possible until you get to your final answer, which you can round to 3SF then. So we're going to keep 14.0041 for now. We found FC, so we can write in here now our value for FC, which is 14.0041 ... centimeters. Now we just have to find AC. And to find AC, we can consider this triangle on the floor right there. It's also a right angle triangle. So let's go ahead and draw that. So this is D, this is C, this is A. We know that A to D right there is 30 centimeters. And we know D to C here is 20. So we can write that in. So 30 centimeters and 20 centimeters. And what are we finding? We are finding A to C, the length A to C, which is right there. And of course, A to C is right there too. So we are going to call this the letter Y because we've already used X for the other triangle. So on this triangle, what do we use to find the value of Y, the length Y? We won't need to use trigonometry. We can use Pythagoras because Y is our hypotenuse. So A squared plus B squared is equal to C squared. And let's go ahead and label our triangle. This is the important one. We need to call the hypotenuse C, and this can be A and this can be B. So A squared, which will be 20 squared, plus B squared, which is 30 squared, is equal to Y squared. And if you do 20 squared plus 30 squared, you'll get 1,300. So Y squared is 1,300. And if you do the square root of 1,300, you get Y is equal to 36.05551 ... Again, keep as many values as possible so that you don't lose any accuracy in your final answer. So we know that Y is 36.05551. We can now go back up here and say that we know that U are 36.05551 ... centimeters. So now we have our triangle fully completed with two lengths and a missing angle to find. So let's go ahead and label it. So this will be called the opposite side and this will be called the adjacent side. What uses opposite and adjacent? We use tan again. So we are going to do the tan theta is equal to 14.0041 divided by 36.05551, which is practically 14 divided by 36, but we're going to keep some of this accuracy. So now we just need to do the inverse of that. So the inverse of tan 14.0041 divided by 36.05551, that gives us 21.226 5 dot dot dot, and we need to round it to 3 significant figures, so that's going to be 21.2 degrees. And that's your final answer for the angle that the line A to F makes with the plane ABCD. Question 17, it says show that 3 plus this big bracket simplifies to ax minus b over cx minus d, where a, b, c and d are integers. Okay, so where do we start? Let's start by simplifying and dealing with what's inside that big square bracket, and then we can deal with this 3 outside. First of all, write x plus 4 over 1, make that into a fraction as well. And what do we do when we have a division? We take the second fraction and we flip it, and the division sign changes to a multiply. So we can write times by x minus 5 over x squared minus 16. Now the x squared minus 16 we can factorize. So we can have x plus 4 over 1 multiplied by x minus 5, and this becomes difference of two squares. So we're going to have x plus 4 and x minus 4. Now you can see that x plus 4 is here and here, so you can cancel them out. So you end up with 1 over 1 here times by x minus 5 over x minus 4. And this just simplifies to x minus 5 over x minus 4. So all of that is simply what we simplified this big bracket into. Now we just have to deal with that 3 on the outside. So therefore 3 plus x minus 5 over x minus 4, and we will make first of all that 3 into a fraction by doing over 1 plus x minus 5 over x minus 4. We want to have the same denominators, so what do? We multiply the 3 over 1 with this one's denominator, giving us 3 bracket x minus 4 over x minus 4 plus x minus 5 over x minus 4. Now we have the same denominator, we can just deal with the numerator by expanding it and then collecting all the like terms. So if we expand the bracket on the first fraction, we get 3x minus 12, and we get plus x minus 5, and then we get that all over the same denominator, which is x minus 4. Collect the like terms on the top, so 3x plus x is 4x, and minus 12 minus 5 is minus 17. So we get 4x minus 17 over x minus 4. And now we have our form that they wanted, which is ax minus b over cx minus d. Question 16. The two triangles in the diagram are similar. Let's highlight that word. There are two possible values for x. Work out each of these values, state any assumptions you make in your working. All right, let's go ahead and draw these two triangles out separately. So what we're looking at, we are looking at this triangle right there and the larger triangle right there. So the first one is A, B, E, that's 6 centimeters, and this is 5 centimeters. The second one is A, C, D. This is going to be 5 plus 4 because you add those two up. So it's going to be 9 centimeters, and this is going to be 6 plus x. So 6 plus x. Now, there are two possible values of x. I've made an assumption that this side here marries up with this side there. But it could be that this side is with that side. We don't know. We know that they are similar. So an alternative arrangement for these triangles could be in the following way. We could have our A, B, E here. So this is 6 and this is 5 centimeters. And on the second one, we could have A here, we could have C here, and D could be up here. So A to D here could be 6 plus x, and A to C is 9 centimeters, which we could have down here. So now what will happen is this side will be with that side, and this will be with that one. Now, why do I do all this? Because when we calculate the scale factor, then this will change what the scale factor is depending on which side we use with which. So if we were to calculate the scale factor for the blue triangle variation, then we're going to have 9 divided by 5 is equal to 6 plus x divided by 6. And we're just going to solve this. So we get 9 times by 6 is equal to 5 times by 6 plus x. 9 times by 6 is 54, is equal to 30 plus 5x. And then we take the 30 to the other side, so we have 24 is equal to 5x, and therefore x would be equal to 24 divided by 5, which gives us 4.8 centimeters. So 4.8 centimeters is one of the possible values of x. If we go with the pink variation of the triangles, then the scale factor would be 9 divided by 6 is equal to 6 plus x divided by 5. So it will be 9 divided by 6 is equal to 6 plus x divided by 5. And if we do the same thing, solve this, so 9 times by 5 is equal to 6 bracket 6 plus x. 9 times by 5 is 45, and that gives us 36 plus 6x. We take the 36 to the other side, giving us 45 minus 36, which is 9, is equal to 6x, and then 9 divided by 6 is equal to x, so therefore x would be 1.5 centimeters. And that's our second value of x. So 4.8 and 1.5 are our two possible values of x. Question 15. A and C are points on the circumference of a circle with the center O. B to C is a tangent to the circle, and angle CAB is equal to 29 degrees. Find the size of angle ABC, showing all your working. So angle ABC, we are looking for this angle right there. So let's go ahead and mark that. That's what we're looking for, angle X right there. Now what we're dealing with, we are dealing with a tangent to a circle. We know that the tangent meets the radius at 90 degrees. So this right here is 90 degrees. Let's go ahead and draw that triangle out. So we have a right angle right there. This is O, this is C, this is B, and this is the X that we are looking for. Now, what do we know? We know that this here is a radius and this here is a radius, making this triangle right here an isosceles triangle because these two sides are equal. So this angle right here is 29 degrees. So let's now draw this larger triangle out. So we have A here, we have B here. This is our X that we are trying to find. We have C here. We know that all of this is simply all of that. So it's going to be 29 plus our tangent, which is 90. So this angle right here is going to be 119 degrees because it's going to be 29 plus 90 degrees. We also know that this is 29 degrees, so this is 29 degrees as well. So how do we now find our x? Well, we know that the angles in a triangle, all of these, add up to 180. So it's going to be 180 minus our 29 minus our 119 degrees, and that gives us a total for x, which is 32 degrees. So x is 32 degrees. Now a question might say to you, give reasons for your answer. This question doesn't say it, but an exam question in the final exam might. So what are the reasons that we have? We have an isosceles triangle. We have a tangent meets the radius at 90 degrees. And we have angles in a triangle equal 180 degrees. So this is our final answer for the angle ABC, and these are our reasons. Question 14. A car's value is decreasing by X% each year. The car's value will decrease by 60% in 6 years. Work out the value of X. Give your answer to 2 decimal places. Now, where do we start with this question? We know that it's a percentage decrease problem. We are told that it's decreasing by X% each year. We also know that after 6 years, the value of the car has decreased by 60%. So let's write down something from that piece of information. So a decrease of 60% is going to be 100% minus 60%. That gives us 40%. And to work out the multiplier for 40%, just divide by 100. So the multiplier would be 0.4. So let's give a value to the car. Say £1,000. Let's say the car costs £1,000. So if the original amount of the car is £1,000, and it has decreased by 60%, so we're going to multiply it with a multiplier of 0.4, this gives an amount of £400. So the value of the car after 6 years is £400. This means that if I were to take the original value of the car, let's say 1,000, as we said, times it by our multiplier, which we know is a decrease of X% each year, so times by X, to the power of 6, because we are dealing with compound interest here, we have to have a value of £400 after 6 years. So we're just going to deal with this algebraically by solving this. 4x. So the first thing we're going to do is divide by 1000. So we're going to have x to the power of 6 on this side, and we're going to do 400 divided by 1000. Division, because it's the opposite of multiplying, and we want to get rid of the 1000. This gives us x to the power of 6 as 0.4. And to find what x is, we do the 6th root of 0.4. And that gives us 0.85837 ... We want to work out what the multiplier is. Now you can see what the multiplier is by looking at that. But you could also multiply this by 100%, and multiplying by 100 will give you 85.837 ... So if you do 100% minus 85.837 ... to 2 decimal places, you get 14.16%. So the decrease is by 14.16% every single year. Question 13, we have a column vector question. We are told that A is minus 2, 3, and B is 5, minus 1. Quick reminder, when you have a column vector, then this is your X and this is your Y. So A plus B is simply going to be minus 2 plus 5 and 3 minus 1. All I've done is added those two and added those two, giving me 3 and 2. So that's my answer for part A. For the second part, I multiply A by 2 first, so minus 2, 3, and then I take away 5 minus 1. So when I multiply this by 2 first, I get minus 4, 6, and 5 minus 1. Now I will just do minus 4 minus 5, giving me minus 9, and I will do 6 minus minus 1, and the minus minus is a positive, so it will be 6 plus 1, which is 7. So the answer is minus 9, 7. Right, question 12, expand and simplify. We can do this one of two ways. We can either leave this untouched and multiply this, or we can choose to leave this untouched and multiply this and then deal with that bracket later. I'm going to leave this untouched and multiply those two, so let's go ahead and do that. So I'm going to do x times by x, which is x squared, x times by minus 3, which is minus 3x, and then 5 times by x is plus 5x, and then 5 times by minus 3, which is minus 15. And the second bracket will be 2x minus 1. Collect all the like terms here, so I have x squared plus 2x minus 15 and 2x minus 1. Now I'll expand with the 2x minus 1 bracket. So this will multiply with that, and then this. So I get 2x cubed minus x squared. Next I will do 2x times by 2 and 2x times by minus 1, giving me plus 4x squared minus 2x. And finally I'll do minus 15 times by 2x, which is minus 30x, and minus 15 times by minus 1, which is plus 15. Now all I have to do is collect all the like terms. So I have this and that to collect together, and this to collect together. So 2x cubed plus 3x squared minus 32x plus 15. And that is my final answer. Question 11. The line A to B passes through the points A minus 2k and 4, 8. The gradient of A to B is minus 2. Work out the value of k. And the formula for gradient is y2 minus y1 divided by x2 minus x1. Simply the two y coordinates taken away from each other and the x coordinates taken away from each other. So what does that give me? That gives me 8 minus k over 4 minus minus 2, which is 8 minus k over 6. Now we are told that the gradient is minus 2. So what I can write down is minus 2 is equal to 8 minus k over 6. And I just solve this for k. So I'll multiply with the 6, giving me minus 12 is equal to 8 minus k. Take the k onto this side to make it positive and minus 12 onto that side. So therefore k would be equal to 8 plus 12, which is 20. So the value of k is 20. Question 10. There are 5 starters, 6 main course, and X desserts in a restaurant. Riley says there are 130 ways of a starter, a main, and a dessert. Could Riley be correct? Show your working. Right, so we know that there are 5 starters. We're going to multiply this with the 6 main course, multiplied by the X amount of desserts. Now, could this be equal to 130? That's what we're trying to find out. So 5 times 6 is 30, and times by x is 30x. We have in total as equal to 130. Now, we're going to do 130 divided by 30. That gives us 4.3. Now, can x be 4.3? No, it can't, because x is the number of desserts and it has to be a whole number. So no, you can't have decimal values for the number of desserts. Has to be whole numbers. Okay, question 9. Given that 81 times root 3 is equal to 3 to the power of n, find the value of n. How do we do this? Right, so if we have a look at this, we want to make everything into 3 to the power of something. So we can make root 3 as 3 to the power of a half. Now what about 81? Well, 81 we can write as 3 to the power of 4. So this entire thing here would simply be 3 to the power of 4 times by 3 to the power of a half. And what do we do with this? Well, we just add the powers because we are multiplying. So we are just going to do 3 to the power of 4 plus a half, and 4 plus a half is 3 to the power of 9 over 2. So the value of n is 9 over 2. Question 8. We have question 8. ABCD is a trapezium. Calculate the area of ABCD. Okay, so we want to calculate the area of this. We can split this up into two separate shapes right there. So let's go ahead and split this shape up like this now. Let's call this one A and let's call this B. So if we draw this shape A, which is a rectangle, separately, we have this as 15 centimeters. We don't know just this length here because we don't have the value of that to take away from 12. So what we're going to call this is X. If we draw our triangle as well, so shape B, we know that this is 15 because that's 15. So we can write 15 centimeters right there. It's a right angle triangle, by the way. And we know this length is 17. So we can have 17 centimeters right there. Now, once again, we don't have a value for this, but what we can do is, since we called this side X, we can just say 12 minus X, which would be equal to just this. So that can be called 12 minus X. Now, if we were to calculate the area of shape A, it will be 15 times by X, so it's 15X. Now for this shape, we're not going to write down an expression for the area. What we are going to do is use Pythagoras' theorem to find the value of X. Because we've got all three sides, we can use Pythagoras' theorem to set up an equation. So what equation can we set up? Let's call this C, let's call this A, and let's call this B. So we know that A squared plus B squared is equal to C squared. So A is 12 minus X squared, B is 15 squared, and that's equal to C squared, which is 17 squared. So 12 minus X, that bracket will expand to 144 minus 24X plus X squared, and 15 squared is 225, so plus 225. And that's going to be equal to 17 squared, which is 289. Now we're going to take everything over to one side and simplify it. So we have X squared minus 24X plus 80 equals to 0. So to factorize this, you can use any of the methods that you know for factorizing, but I'll go straight into the brackets. So we have X here, we want to make 80. We know that 20 times 4 gives you 80. We have minus and a minus, so therefore X will equal 20 and X will equal 4. Now we have to decide which value of X we can take, because you can't take both of them. So in order to do this, if you have a look at the side that says X, 12 minus X. So we can't do 12 minus this value of X because this value of X is 20, and 12 minus 20 would be a negative answer, would be minus 8. So therefore this is not our valid answer. We would just want to use X is equal to 4. Now that we know the value of X is 4, we can go ahead and calculate the full area. And we can do this in one of two ways. We can either find the area of the rectangle and add it to the area of the triangle, or we can look at the trapezium as an entire shape, because now we know the value of X here is this value of X right there, and we have the two parallel sides. So we can write X here as 4. So the whole trapezium would look like this. So this is 4, this is 12, and the height is 15. And when you want to find the area of your trapezium, you're going to do 12 plus 4 times by 15, and divide that by 2, and that gives you 120 centimeter squared, which is the area of your ABCD. Okay, so question 7. Potatoes cost £9 for a 12.5 kilogram bag at a farm shop. The same type of potatoes cost £1.83 for a 2.5 kilogram bag at a supermarket. Where are the potatoes the better value, the farm shop or the supermarket? So at the farm shop, you are paying £9 for every 12.5 kilos. So you just do 9 divided by 12.5. And that gives you 0.72. So you're paying 0.72 per kilogram. At the supermarket, you're paying £1.83 per 2.5 kilograms. So £1.83 divided by 2.5. And that gives you 0.732 per kilogram. So the farm shop is cheaper because you are paying 72p per kilo, whereas at the supermarket, you're paying 73.2p per kilo. So question 6, Amy drives 300 miles from London to Newcastle. She drives the first 165 miles at an average speed of 60 miles per hour. From this point, it takes Amy 3 hours and 5 minutes to complete her journey. What was her average speed for the whole journey? Right, so we are going to be using the DST formula. So let's work out the time for her first 165 miles. So time is going to be equal to, so we want to find what t is, so it's going to be d divided by s. So time is going to be distance divided by speed. The distance that she travels is 165 miles and the speed that she travels at is 60. So work this out on your calculator, you get 2.75, and that's in hours, the time. So this would be 2 hours, and then this would be 0.75. It's in hours, so you need to make that into minutes. So you have to times it by 60, and that gives you 45 minutes. So in total, it takes 2 hours and 45 minutes on the first part of her journey, where she travels at an average speed of 60 miles per hour. Then from this point, it takes Amy 3 hours and 5 minutes to complete her journey. Now what we can do is work out her total time. So we are going to add the 2 hours and 45 minutes to her 3 hours and 5 minutes. So 3 hours and 5 minutes plus 2 hours and 45 minutes. That gives us 5 hours and 50 minutes. Now we need to find her average speed for the whole journey. So we'll require the speed is equal to the distance divided by time formula. So speed is equal to distance divided by time. Now the total distance, we want to find her speed for the whole journey. So the total distance is given to us as 300 miles. So it's going to be 300 divided by the total time, which is 5 hours and 50 minutes. Now we can't put 5 hours and 50 minutes like that because this is in hours and minutes. We need to convert all of this into hours only because time here needs to be put into hours. So this 50 minutes we need to make into an hour. So how do you do that? So we've got the 5 hours already, so it's going to be 5 point something, and the 50 minutes we are simply going to do 50 divided by 60, and that gives us 0.83 recurring. So we can write 5.83 recurring, and there is a button on your calculator to show recurring, but if you were to just put 5.83, it won't be a problem because it won't be too far off the final answer. And now this gives us 51.4 miles per hour. So this is her average speed for the entire journey. Question 5. There are 120 people in a school canteen. 40% of the people in the canteen are Year 11 students. The number of Year 11 students in the canteen is 3 times the number of Year 10 students. The rest of the people in the canteen are Year 9 students. The ratio of the number of Year 9 students to the ratio of number of Year 10 students is n to 1. Work out the value of n. You must show how you got your answer. Right, let's begin with Year 11 first. So we know that 40% of the students, and there are 120 of them, so 40% of 120 is what we need to work out. That is a calculator job, so 120 times by 0.4, that gives you 48. So there are 48 Year 11 students. Now to calculate the number of Year 10 students, well, we know that the number of Year 11 students in the canteen is 3 times the number of Year 10 students. So if there are 48 Year 11 students, then you do 48 divided by 3 to get your number of Year 10 students, which is 16. So there are 16 Year 10 students. Now we just need to calculate the number of Year 9 students. We know that there are a total of 120 people in the canteen, and we are told that the rest of the people in the canteen are only Year 9 students. So in order to find out how many Year 9 students there are, we do 120 minus the 48 Year 11 students minus the 16 Year 10 students, and that gives us 56. Finally, we can now put it into this ratio right here. So the number of Year 9 to the number of Year 10 students is in the ratio 56:16. We just need to make this 16 into a 1. How do we do that? By dividing by 16, both sides. So 16 divided by 16 is 1, and 56 divided by 16 is 3.5. So the value of n here is 3.5. Okay, question 4. S is equal to ut plus half at squared, u is equal to minus 5, a is 4, t is 3. Work out the value of s. So we just need to substitute those values in. So s is going to be equal to u, which is minus 5, times by t, which is 3. So minus 5 times by 3, and then plus a half times by a, which is 4, times by 3 squared. And we can just put this into our calculators. So for the first part, we get minus 15. And for the second part, half of 4 is 2. And 3 squared is 9. So 2 times 9. And therefore, we get minus 15 plus 18. And minus 15 plus 18 is 3. So the value of s is 3. Next, we are told to make a the subject of our equation. A is right there. We have to isolate it. We have to get rid of everything around it. So the first thing we're going to do is take the ut to the other side. So we get s minus ut is equal to a half at squared. Next, we are going to get rid of the half by multiplying by 2. So if we multiply by 2, we get 2s minus 2ut is equal to at squared. You might be wondering what happened to the 1. Well, when we multiplied with the 2, then we only were left with 1 times at, and we don't need to write 1 in algebra. Next, we are going to divide by t squared. So we're going to have a is equal to 2s minus 2ut all over t squared. And now we have a as our subject. So a would be equal to 2s minus 2ut all over t squared. Right, question 3. The value of a house increased by 6%. The house then had a value of 265,000. Work out the value of the house before the increase. Okay, so we can use the formula original amount times by the multiplier is equal to the new amount. We don't know the original amount because that's what we're trying to find out, so we're going to call it an x. The multiplier, now we know that it's increased by 6%. So an increase of 6% is going to be 100% plus 6%, which is 106%. And 106% as a multiplier is divided by 100, so 1.06. So our multiplier is going to be 1.06. And the new amount is going to be what the value of the house is after this increase, which is 265,000. So 265,000. Now to find what x is, we are going to do 265,000 divided by 1.06. And that gives us 250,000 pounds. So 250,000 is the value of our house before the increase. Question 2. Banana Computers sold 19.3 million computers in 2017. In 2018, they sold 18.2 million computers. Work out the percentage decrease in the number of computers sold. Give your answer to free SF. So to find the percentage decrease, you do difference, divide by the original, times by 100%. The difference is simply 19.3 minus 18.2, and the original amount is 19.3. And you times that by 100%. So that gives us 1.1 divided by 19.3 times by 100%. The answer is 5.69948 ... So we want to give this answer to free SF, so it's going to be 5.70. So 5.70 is the percentage decrease in the number of computers sold. Finally, the last question, hope you're still here. The frequency table shows the heights in centimeters of some tomato plants. Draw a frequency polygon to show this information. Right, with the frequency polygons, it's important that you understand that you plot at the midpoints of these values, these class intervals. So 140 to 150 is going to be 145. So 145 is in the middle here, and you just go and find what 7 is. Now, before you do these questions, you've got to work out what each of these squares mean. So if you have a quick look here, you can see that 1, 2, 3, 4, 5. So every 2 squares is equal to 1. So a 7 would be right there. Next, you do 150 to 160, so the midpoint of that is 155 right there, and you go up to 10, so that's going to be right there. 160 to 170, the midpoint is 165, so you're going to find 15 on 165, which is right there. 170 to 180, the midpoint is 175, so you're going to find where 19 is from there, and 19 is right there. And finally, 180 to 190, the midpoint is 185, so you're going to find where 9 is from there. Now all you have to do is draw a line through them. So using your ruler, there you have your line. Now most examiners will be happy with this, no problem, but what I'd like to say to you, my students, is it goes down to 140 and it goes up to 190, so you can also do this and complete the full polygon with the x-axis, and there is your final answer. But both of them would be accepted from the examiner, whether you go down to 140 and 190 or not. Hope you enjoyed this lesson, guys. If there's something that you didn't understand, you can go back and rewind and rewatch it again. And also do check if any of these lessons are on my channel, because most of the topics have been covered by now for GCSE Maths. So just go on to the different playlists that are there, or do a search on the channel, and you should be able to find a lesson which explains these topics in a little bit more detail than I have done so on this paper. I couldn't explain it in so much detail due to the time and this video just becoming too long. If you haven't done so already, please do subscribe to the channel and don't forget to hit like for this video. See you in the next one, guys. Bye for now.